When most people think of Amazon, they see the boxes on their doorstep, the website, the whole everything store. But the real secret to its insane success isn't really about retail at all. It's about the database architecture that kind of quietly ended up conquering the world. This is the story of how Amazon's data strategy didn't just build a company, it completely reshaped the internet.
And this right here, this is the core idea of our whole technology investigation today. The website you shop on, that's just the front door. Underneath all of that, Amazon didn't just use databases, they were literally forced to reinvent them from the ground up, and in doing that, well, they changed everything.
So let's just rewind back to the beginning. It's 1995. Amazon launches as this simple online bookstore. But here's the thing you got to understand, the big twist. Jeff Bezos wasn't really trying to build a bookstore. He was building a data pipeline.
And this perspective is absolutely key. Books were the perfect product to get started with. Why? Well, they're all neatly categorized. They have structured data like ISBNs and authors. Every single click, every search, every book you even looked at for a second, that was another data point, feeding this giant machine that was learning about how we shop on a scale that nobody had ever seen before. All that data collection led to this, Amazon's first real killer app, way before Prime or AWS or anything else, the recommendation engine. Now, this wasn't just some clever little feature. It was powered by a massive graph database, one specifically built to map out and calculate all the complex hidden connections between people and products.
So what was it actually tracking? Well, basically everything. It saw who bought what at the same time, it followed your mouse clicks around the page, it knew what you put in your cart and then took out, it even looked at your review patterns. See, Amazon wasn't guessing what you wanted to buy next, it was calculating it. And this engine boosted sales so much it became their first true untouchable competitive advantage.
Okay, so fast forward to the early 2000s. All this incredible success created a huge problem. The entire company, the whole shebang, ran on one giant single Oracle database, a monolith, and it was starting to crack under the pressure. Seriously, one single bad query from a developer could bring the entire website crashing down for everyone.
So they made a pretty radical decision. They decided to just break that single point of failure apart, shatter the monolith, and move to what we now call a service-oriented architecture. But this created a whole new headache. Each of these hundreds of new services needed its own database, and the tools that existed at the time just couldn't handle Amazon's crazy scale. The only way forward was to build their own.
And that necessity, well, it led to this, the legendary 2007 Dynamo paper. This wasn't just some internal memo, it was a blueprint that Amazon published for the entire world to see. It described a completely new kind of distributed database that would go on to inspire the whole NoSQL movement.
One of its core ideas was something called eventual consistency. Think about it like this. For your shopping cart, what's more important? That the database is 100% perfectly consistent across the entire globe at every single nanosecond? Or that the Add to Cart button always works, no matter what, even if it takes a split second for all the data to catch up everywhere? Yeah, they chose availability. And then there was this other huge idea, partition tolerance. Basically, this meant the database could keep humming along just fine, even if servers in different data centers temporarily lost connection with each other. For a global retail site, this kind of resilience wasn't just a nice feature, it was an absolute non-negotiable requirement.
The paper laid out this whole new philosophy built on some really groundbreaking concepts. It used decentralized designs where no single server was the boss, and clever protocols that let servers just gossip among themselves to share updates. This whole approach enabled a massive shift away from scaling up, building one giant expensive supercomputer, to scaling out across thousands and thousands of cheap, regular servers.
And this is where the story takes an incredible turn. After they solved their own massive scaling problems, the folks at Amazon had a world-changing realization. They looked at the powerful, scalable infrastructure tools they'd built for themselves and understood just how valuable they were. And they thought, what if we could rent them out to other companies?
And boom, Amazon Web Services was born. Just look at this timeline. S3 and EC2 kicked things off in 2006, giving developers raw storage and computing power. Then came the databases themselves. DynamoDB in 2012, the commercial version of that internal Dynamo system, and then Aurora in 2014 for more traditional database needs. Amazon wasn't just a store anymore, it was literally becoming the backbone of the internet. And the scale of it today is it's staggering. Companies that are household names, I mean, even Amazon's direct competitors in streaming, like Netflix, they run on AWS. It's wild. They built a database empire to run their own business and then successfully rented it out to the rest of the world.
So how does this whole database-first way of thinking show up in Amazon's business today? Well, the answer is pretty simple. It's everywhere. It's not just the website. It's the entire operational machine, from the robots in the warehouses all the way to their physical stores.
Take the Amazon Go stores, for example. I love this quote because it's just so perfect. Using computer vision and a ton of sensors, the entire store acts as a living, real-time database. It logs every single item you pick up, every movement you make. You're not just shopping, you are literally walking through a database. And that brings us to what the modern stack looks like. See, Amazon doesn't just use one database, it uses a whole constellation of specialized databases. They really pioneered this idea of using the right tool for the right job. DynamoDB handles the massive scale of the shopping cart, Aurora takes care of traditional relational stuff, Redshift crunches petabytes of data for analytics, Neptune handles those graph relationships. They didn't just adopt modern data architecture, they actually defined it for everyone else.
So, as we start to pull all these threads together, our investigation makes it really, really clear what the true engine of Amazon actually is.
If you take away one thing, it should be this. The website you use is just the interface. The warehouses and all the robots are just the execution layer that gets the product to you. The core of the business, the real product, is the data architecture that powers everything, driving both its retail empire and the cloud platform that runs a huge piece of the modern world. And that leaves us with a pretty fascinating final thought to chew on. Amazon built a system to sell everything, but in that process, they accidentally built a system to know everything. So what really happens when the world's biggest store is also the world's biggest, most sophisticated database? That's a question we're thinking about.